So in yesterday's class, we have discussed source transformation, right? What is a source transformation technique? What is source transformation? Yes, tell me what is the source transformation technique? Source transformation is to interchange the voltage source to current source. That means voltage source can be converted into a current source. That means a practical voltage source. That means it has a voltage source in series with a resistor, and current source means a practical current source consists of a current source in parallel with a resistor. So we can convert a voltage source to a current source and current source to the voltage source, right? Am I audible?
Yes, sir.
Yeah. So that is the source transformation. It is required in some problems. Suppose if you find any difficulty in solving the problems using either mesh or node analysis, or sometimes it is required to combine some kind of techniques. So there the source transformation is useful for you to analyze a network, right? Yesterday I have given you two problems. Did you solve this one? See, the first problem is given like this. In this we need to find the power delivered by the 5 ampere current source. So as I explained in the last class, to apply the nodal analysis, since there is a voltage source between V1 and V2, so take it as a super node, and the third node there is a node V3. So three equations I have given you. The three KCL equations we have written already in the last class. Did you solve that problem? Anyone solved that one? Please respond. Anybody solved that problem, the first problem? Anyone? G6? 4G6.
Yes, sir.
Did you solve the problem?
No, sir.
Why? Already I have given KCL equations and I explained the procedure also. What is the problem? What is the problem for you to solve the problem? Now you solve this one. Already equations are there. Everyone? Okay, it's okay. G6. Everyone solve this problem now. Already KCL equations are given. 3 equations. And a simplification also. I have given you a simplification also. It is V1. We can remove the V1. V2, V3 are there. One equation is V2, V3. And the relation between V1, V2 is given as 10. Solve this one. V1 minus V2 is given as 10. You can use this equation. So take the first equation. Take the first one, 0.33 V1 plus 1.2 into, for V2 from the equation 3 you can substitute V2 is V1 minus 10 plus, minus 1.33 into V3. See, from this simplified equation, that is equation 4, there is equation 4. So from this, can we write V3 in terms of V2? V3 is 0.2 V2 minus 3 by 0.5 is equals to 3. So again V2, we know V2 is V1 minus 10. We can write V2 as V1 minus 10. This V2 as V1 minus 10. So now we can simplify all, because this equation is completely converted into V1. Only one unknown, 0.33 V1 plus 1.2 V1 minus 12 minus 1.33 by 0.5 into 0.2 V1 minus again 12 minus 3 is equals to 3. Right, this is, in this way you can simplify. You can simplify this one. 1.33 divided by 0.5 is 2.66. This value is 2.66. You can multiply this at 0.33 plus 1.2, that is 1.53. First two terms gives 1.53 V1 minus 12 minus 2.66 into 0.2, 0.532, 0.532 V1. This is minus into minus plus 2.66 into 15. 2.66 into 15 is 39.9. Approximately it is 40 is equals to 3. 1.53 minus 0.53, that is V1. 40 minus 12 here. 40 minus 12, 28. There's something wrong. Where we got wrong here. Point 33. Somewhere calculation is missing, I think. Are you solving? Actually, the answer need to get is let me check this problem. This is 2 amperes. Yeah, 2 amperes, 1.2, 5 amperes, 5 ohms, 2 ohms, 1 ohm, and 3 ohms. Somewhere calculation gone wrong, I think. Here, see this one, we'll do it again. Let's simplify this. This is wrong, I think. Equations are the same. First equation is 0.33 V1 plus 1.2 V2 minus 1.33 V3 is equals to 3. One more equation is minus 0.34 V1 minus V2 plus 1.83 V3 equals to 0. V1 minus V2 equals to 10. Equations are right, but answer in calculation, there might be some mistake. To solve this one, the values are V1 is 13.72 volts, V1 value. V2 is 3.72. V3 is 4.567. V3 is 4.567. So these are the answers, right? So V1 value, V2. Equations are correct. The given equations are correct. Whatever the equations, KCL equations we have written are right. And solve these three. Solve these equations, and these are the answers: V1, V2, V3. What we have to find? We have to find the power delivered by the source. So V2 into 5, power delivered by the 5 ampere current source. V2 is 3.72. So power delivered is 3. Here V2 is 3.72 into 5. So this is 18.6. The answer, power delivered by the current source is 18.6 watts. Okay. You try to solve this problem for the values, the given values. Answer is given. To find the power. Right? Are you following? Okay. Then next problem, one more I have given, I think. Second problem also I have given. So this is the second problem. For this, what we need to find? What is the problem I have given for this? For a second problem, what we need to find? Is it the current? I think it is current flowing through 10 ohm.
Yes, sir.
Current through 10 ohm. Current flowing through the 10 ohm resistor. Right? So for this also I have given the equations. Because we simplified this circuit like this. So because to apply this is the actual circuit given, the first one. So we simplified in this way. Because these nodes are same, so we use the mesh analysis, and since there is a current source, we formed the super mesh and then applied the equations. Is there any other procedure to solve this problem from the concepts whatever we have discussed? Is there any other procedure? Anyone from the class? So I modified the circuit like this to apply the mesh analysis. Any other procedure is there? Because we have discussed so many concepts so far. Is there any other procedure to solve this one? Source transformation. Can we apply source transformation to the circuit at any point? Say yes or no. Can we apply source transformation or not? See, if you observe this part, what is this part? What that red circled portion consists of? What is that red circled portion? Current source in parallel with a resistor, right? Current source in parallel with a resistor. Can we replace that with a voltage source in series with a resistor, so that we will get only one branch? Are you following or not? By applying the source transformation, yes or no? G4, 4G4. Is there 4G4, 4G5?
Sir,
Can we apply source transformation? Is it further simplifies or not? Is it useful applying source transformation to the circuit? Chappandi. Is the source transformation is useful or not? Okay, source transformation. If you observe this one, source transformation converts this two branches into a single branch, because this is a current source in parallel with a resistor. Current source in parallel with resistance. Use the source transformation. That means if it is replaced by a voltage source in series with a resistor, it will be useful and it gives a single branch, right? So to apply the source transformation, the voltage source, what is the voltage source value? We need to write Vs is Is, that is 2 amperes, into resistance R20, that is a 40 volts resistance in series with a 20 ohm resistor. This is Rs. So we can redraw the circuit. This is one method. Already whatever we have discussed in the last class, this is one method to solve the problem. Both will give the same answer. Both the procedures will give the same answer for 10 ohm resistor, current through the 10 ohm resistor. Now we can redraw the circuit after applying the source transformation. That means in the middle branch we can replace the current source in parallel with the resistor with a voltage source of 40 volts. Voltage source of 40 volts in series with a 20 ohm resistor, and last branch 10 ohm with 36 volts battery. So now this is the equivalent circuit we got. Finally, another equivalent circuit. This is one equivalent circuit without applying source transformation. The second one is with applying the source transformation. Okay, this is also, even if you apply any technique, both techniques, you will get the same answer. So for the current, that is the current flowing through 10 ohms. But in the first problem, if you want to simplify the problem using this technique, first technique, we got 3 currents. In the second problem, only 2 are sufficient. I1 in the first loop, I2 in the second loop. I2 in the second loop. So here it becomes I2. In the first case, it is I3, current flowing through the 10 ohm. In the second case, it becomes I2. It becomes I2. Right? To simplify this, write the KVL equations. We'll get the same value for the current flowing through the 10 ohm resistor. See, if you respond, if you are interactive in the class, I can discuss more problems. So different types of problems. So now tell me the KVL for this first loop. What is the KVL for the first loop? The second simplified one. Is my voice is audible? Am I audible?
Yes, sir.
Is presentation is visible? The problem?
Visible, sir.
Okay. Yes. Tell me the KVL. 24 minus 5I1 minus 20 into I1 minus I2 minus 40 volts is equals to 0. This is the first equation. So that is minus 5I1 minus 20I1 plus 20I2 minus 16 is equals to 0. So if you simplify this, you will get minus 25I1 plus 20I2 is equals to 16. Right? This is the first equation. By applying KVL to the first one, we will get minus 25I1 plus 20I2 is equals to 16. Right? So now apply the KVL for second. For second loop, write the KVL. For second loop, I am writing here 40 volts minus 20 into I2 minus I1 minus 10I1 minus 36 is equals to 0. You simplify this one, 40 minus 20 plus 20I1 minus 10I1 minus 36 equals to 0. So 10I1 minus 20I2, here 40 minus 36, 4. That is a minus 4. So second equation is 10I1 minus 20I2 is equals to minus 4. Right? Second one is 40 minus 20 into I2 minus I1 minus 10 I2, not I1 this. 10 I2. This is I2, not I1. I think nobody are writing the equations. So this is I2. So that means minus 30 I2. 20 I1 minus 30 I2 minus 30 I2 is equals to minus 4. This is the second equation. Right? Now solve the two equations. Solve these two equations. We have only two equations in this case, because we have applied the source transformation technique. So it is further simplified. We got only two equations. Minus 25I1 minus 25I1 plus 20I2 is equals to 16. The second equation is 20 I1 minus 30 I2 is equals to minus 4. Right? Two equations. We need to find I1, I2. So two unknowns only. So simplify these two equations. Okay. So simplify. Multiply this with 20 and this with 25. So the first equation you will get is minus 250 I1 20/20s plus 400 I2 is equals to 320. This is 250
Sir,
I1.
minus 500 I1. Sir.
Huh?
Minus 500 I1, sir, first one. 25 into 20.
20. Okay, right. First one is 25 into 20. Right. 500. Second one is 500 I1 plus 25 threes. 25 into 30.
750.
750. This is minus 750 I2 is equals to minus 100. Right? So this is 750 minus 400, 350 minus 350 I2 is equals to plus 320 minus 100, 220. Right? 220. So I2 is equals to 220 by 350. 220 divided by 350. 0.6285 minus, right? Minus is there, minus 0.6285 amperes, right? I2 is minus 0.6285 amperes. Now you can find I1 in the similar lines. You can find I1 value, but we need the current flowing through 10 ohms only. No? So 10 ohms means I2 only. The current flowing through the 10 ohms means it is I2 only. So I2 is minus 0.6285 amperes. That means actually the assumed direction is clockwise. So, but the current flowing through the 10 ohms is in this direction because we got negative sign. So 628.5 milliamperes of current flowing in the anti-clockwise direction in the second loop. Okay. So the first simplified circuit, you do it as a homework. The first simplified circuit, whether you got the same answer for the current flowing through the 10 ohm resistor is same or not. We will get the same answer. I solved the same, that one also. You will get the same minus 0.629 amperes for that one also. Okay. So, but if you know the source transformation, before knowing the source transformation technique, so you can use the first one for this simplified circuit. Because the node, based on the nodal analysis, you know the 2 ampere source and 20 ohm are connected between a pair of nodes. So you can modify the circuit like this as a first case. But if source transformation is there, you know the source transformation, then it is easy because current source in parallel with resistor can be replaced with a voltage source in series with resistor. So instead of two branches, here you get only one branch. So the circuit complexity is reduced. So in the original problem, there are 2 branches. It is modified to 1 branch only. So you can apply the KVL easily. Only 2 KVL equations can be used to solve this one. Okay, right? Did you finish this one? In the problem, only one thing is asked, that is current flowing through 10 ohm only. So it is enough. Only the I2 is enough, right? I have noted down that problem. You draw the 2 circuits, 2 equivalent circuits. Already we evaluated the current flowing through the 10 ohm resistor for one simplified circuit. You solve the second one also. Tomorrow you solve that second problem. That means second simplified circuit, and check whether you got the same answer or not, right? Now we will solve one more problem. Draw the circuit, one more. Find the loop currents for the circuit. Find the loop currents. How many loops are there in the given circuit? First note down the circuit. So how many voltage sources? 1, 2, 3 voltage sources are there. 10 volts, 20 volts and 30 volts. 3 current sources, 15 ampere, 10 ampere, 5 ampere. Resistors, 1 ohm, 4 ohm, 10, 16, 20 and 8 ohms. So somewhat complicated. 4 loops are there. Is it required to apply KVL to all the loops to find the loop currents? Is it necessary to find the loops, KVL to all the loops? Is it required? Mesh, 4 meshes. Any super mesh are there in the circuit? Any super mesh? So total how many KVL equations are required to solve this problem? Tell me how many KVL equations. Yes. Anyone from the class? How many KVL equations are required? See, suppose if I write the nodes as see, this is the first loop, 1 I1. Assume this is the first loop I1, second loop I2, third loop I3, your fourth loop I4. Right? So, is it required to apply 4 KVLs? Yes or no? 4 KVLs are required? No, 5 ampere source is there in between I1 and I2. So it forms a super node. One more, 10 ampere is there between second loop and fourth loop. So this is also a super mesh. Sorry, super mesh between 1 and 2 and super mesh between 2 and 4. And 15 amperes is there at the outer loop. So we can neglect this that branch, outer loop branch. Only that relation, we can take the current relation from that. So we will get the, how many KVL equations? Tell me how many? Because super mesh, 2 super mesh equations, that means 2 loops can be combined. Not only 2, 1, 2 can be combined. Similarly, 2 and 4 can be combined. Outer loop, this 15 can be neglected. Yes. For F9, F9 is there. For F9, G0, for G0. So how many equations? See, there is a super mesh formed between, if you start here, assume this is a point A, at the node A, start with this node A, minus plus 10 volts, 1 ohm, 4 ohm, and there is a source, 20 volt source, because it is a super node, sorry, super mesh, I1 and I2, between I1 and I2 is super mesh, and you can neglect 10 ampere also. There is one more super mesh, so only this outer loop, 8 ohms, plus minus 30 volts source, because this is also super node, 20 ohms and 10 ohms. So because outer loop, the 15 ampere loop can be neglected. Here the current flowing is I1, here it is I2, here it is I3, this is also I3, here, sorry, this is I4, here I3. So no need to take these, all these currents. So only because super node are formed between loop 1 and loop 2, so combine these 2 loops, first loop and second loop, as well as second and fourth can be combined. So the outermost, that is 15 amperes, where the current is flowing in the outer loop. So this is also neglected, right? So now how many KVLs are required? Yes, how many KVL equations? Only one is enough, right? One KVL equation is enough. Yes or no? Because two super loops, super mesh are there. So one is enough, and we will get the relations as see, if you see the first two loops, I2 minus I1. First two loops, I2 minus I1 is 5 amperes. This is one relation we get. And from 2 and 4, we will get I2 minus I4 is 10 amperes. I2 minus I4 is 10 amperes. And I3 is 15 amperes. From the outer loop, we will get I3 is 15 amperes. These are the relations we will get from the super nodes. Super mesh analysis. So we got already three relations from the loop I1 and I2 common to the 1 and 2. I2 minus I1 is 5 amperes. Similarly, I2 minus I4 is 10 amperes. I3 is the 15 amperes. I3 is 15, right? So now only one KVL, right? That one KVL equation as 10 volts. Start with here 10 volts minus I1 minus 4 I2. I am writing here second loop 4 I2 plus 20 volts plus 20 minus 8 I4 plus 30 volts minus 20 into I4 minus I3 minus 10 into I1 minus I3 is equals to 0. I1 minus I3 is equals to 0. Is it right? 10 volts minus I1 minus 4 I2 plus 20 minus 8 I4 plus 30 volts minus 20 into I4 minus I3 minus 10 into I1 minus I3 is equals to 0. So this is the single KVL equation we got from this problem, and three more relations we got already, that is I2 minus I1 5 amperes, I2 minus I4 10, I3 is the 15 amperes. So use these three relations and simplify this equation, convert this equation into a single variable form and apply this one. Find the loop, we need to find all the loop currents, that means I1, I2, I3 and I4, 4 currents. Okay, so simplify this problem using that KVL and find the loop currents, right? Okay, I will take the attendance now. Please respond to your roll calls.